Alright, this is lesson 2 in unit 3, and here we're going to solve by factoring. So last time we started by factoring, and we factored some simple ones where the leading coefficient in the x squared term was 1 and not a different number. So today we're going to do two things. First, we're going to factor those expressions where the leading coefficient is not 1. Then we're going to solve these quadratic equations by factoring. So, like I said, we did everything where a equals 1, meaning the first term is 1. Or in this case, when we FOILed it, you have x and x. You don't have 2x, you don't have 3x, you don't have 4x. It's both x when we worked on factoring, which is the same as unfoiling. So we're going to try to use the same method. What happens when we FOIL this out and the leading coefficient, the coefficients with the x, are not 1? So let's see what happens. Well, when you multiply this together, you get diamond times club times x squared from the first. From the outside, you get diamond times spade times x. From the inside, you get heart times club times x. And from the last, you get heart times spade. Then you combine the like terms in the middle. That's, by the way, not a good-looking thing. And you get the two terms in the middle. You have diamond times club times x squared plus diamond times spade plus heart times club times x plus heart times spade. Which usually take the first and the third. It's just that really isn't going to work. That's not giving me a pattern that I can see what's going to happen and be able to reasonably guess which the numbers are. So we're going to have to do this different method for unfactoring these. So we're going to have to do this backwards. So let's say we have this, 3x squared minus 16x plus 5. Like I said, we're not going to be able to just say, well, it's two numbers that multiply to give me this and one number that adds to give me this, and then finish the problem. It's going to be longer than that. So the first step is always to multiply the first and the third numbers together. So in this case, it's 3 times 5. So by the way, we have 3, negative 16, and 5, just to clarify that. Multiply the first and the third numbers together, we get 15. 3 times 5 is 15. Now we look at that product that we just got, the 15, and we need two numbers that multiply to give us that 15, but add to give us the middle number, which is 16, because what we're going to do is we're going to work backwards. When you FOIL, you always have 4 terms, then you combine the middle two. So we're going to have to split that middle term up into 2 terms before we can work backwards and solve the equation and factor the expression. So in this case, we need two numbers that multiply to give me 15, that add to give me negative 16, because I need to be able to separate that negative 16 out. So we can pretty much figure that out, not too easily, with a couple guesses and checks. It's negative 1 and negative 15, because when you multiply to get a positive number, they either have to both be positive or both be negative. And since when I add them it's negative, that means they both have to be negative. So I have negative 1 and negative 15. What I'm going to do is I'm going to break that negative 16 up into negative 1x and negative 15x, which are the numbers that I just found there. Now I'm going to factor by grouping. What that means is I take a look at the first two terms and the second two terms independently of each other. So if I just look at the 3x squared minus 1x, I'm going to take out a factor. What do they both have in common? And they both have an x in common. And when I take it out, I divide, because that's undistributing. When you distribute, you put something into the parentheses and you multiply. So when you are factoring, that's undistributing in this case, you're dividing and taking it out of the parentheses. So I'm taking the x outside the parentheses, and what I'm left with, and I divide both terms by x, is 3x minus 1, because x squared divided by x is x. And on the second two terms, I can take out a negative 1, a negative 5, I'm sorry. They both divide 15x and 5x, they both divide by 5, and I'll take out a negative 5 because I want the first term to always be positive. So like I said, with the first two terms, when I take out an x, I'm left with 3x minus 1. And on the second two terms, when I divide both by negative 5, I'm left with 3x minus 1. Now I factor what's left, and you can see the x times 3x minus 1 minus 5, and then parentheses times 3x minus 1. Both of those terms have the 3x minus 1 parentheses, so I can remove that, and I move that outside the parentheses, and what I'm left with is x minus 5. And now I've factored this expression. 3x squared minus 16x plus 5 factors into 3x minus 1 times x minus 5. A little more complicated than what we were doing before, but still not undoable. Now we're going to move on to the point. This is a quadratic equation. See, this is not an expression because it has an equal sign, so it is an equation. And I want to be able to solve that. Well, the traditional method would be to try to isolate the x on one side and then see what's left when you just have x equals. That's a good idea, but in this case it's not going to work because there's no way I'm ever going to be able to combine that x squared and that x. So I'm either going to have more than one x on one side, or I'm going to have an x on both sides of the equation, and I'm not going to be able to solve it. So I'm going to have to do something different. The first thing I'm going to do is factor. But actually before I factor, I want to make sure one key component. In order for this factoring trick to work, not a trick, in order for this factoring method to work, the equation has to equal 0. And you'll see why in a minute. So the first thing I have to do is make the equation equal 0. So right now it equals 5. So the only way to get it to equal 0 is to take away 5 from 5. So my first step, the first thing I want to do is subtract 5 from both sides. And now the equation looks like x squared minus 2x minus 15 equals 0. So far so good. Now you factor the left-hand side. Once it equals 0, you factor it. And when you have factor that, what two numbers multiply to give me negative 15, but add to give me negative 2? The answers are 3 and negative 5. So I factor that, and of course it's still equal to 0. Now I'm going to take an interesting quirk. I know that the quantity of x plus 3, whatever that happens to be, times the quantity of x minus 5, whatever that happens to be, equals 0. So if I consider x plus 3 to be a and x minus 5 to be b, I'm sorry if those are a little off, then essentially what I'm telling you is that a times b equals 0. Now one of the quirks of multiplication is that the only way to multiply two numbers together and get the answer of 0 is if one or both of them is actually 0. Right? If a was 1 and b was 1, they would be 1. The only way to get a 0 for an answer is if one of those two numbers is 0. So what that tells me from back to my factored equation is that either x plus 3 has to equal 0 or x minus 5 has to equal 0. In either one of those cases, then the whole thing is going to be 0. So I'd use that trick. That either means that x plus 3 equals 0, or it means that x minus 5 equals 0. Now I have two pretty simple equations to solve. On the left one, I subtract 3 from both sides, and on the right one, I add 5 to both sides. So in that case, that either means that x equals negative 3, or x equals 5. Quadratic equations have two answers, and you have to give me them both. So that's how you solve quadratic equations. Here's the homework for you. The first page is a couple of factoring with non-1 leading coefficient, and the second one is solving quadratic equations. And you're going to do that by factoring. We'll learn other methods next class. Good luck, and see you next class.